Enterprise AI development often depends on renting remote server clusters. However, a single high-end workstation now has the capacity to run sophisticated agentic loops that previously required a constant cloud connection. The engine for this deployment is Muse Glimmer 30B, an open-weight model designed for high-performance local execution. This specific configuration provides a 1 million token context window and supports the logic required for autonomous software testing. To maintain security, we will isolate the entire deployment inside a hardened virtual machine sandbox, preventing any unauthorized interactions with your primary operating system. Combining open-weight models with a secure local sandbox removes the need for third-party data egress. This setup ensures every part of the AI's decision-making process remains under your direct physical control. The first step is provisioning the virtual machine and enforcing strict network isolation. We are creating an environment that cannot reach the outside internet. Within your network configuration panel, locate the Egress traffic settings. You must manually set this limit to 0 bytes to ensure no data leaves the local host. Before initializing the software, confirm your hardware meets the minimum requirement of a single GPU with at least 24 gigabytes of video memory. With the sandbox sealed and the hardware verified, load the Muse Glimmer 30B model weights into this isolated environment. To fit a 30 billion parameter model onto a single consumer card, we apply an INT4 quantization flag. The framework compresses the model's mathematical footprint to stay within the 24 gigabyte boundary. You must manually restrict the software's VRAM allocation. Set this limit to exactly 22.5 gigabytes in your configuration file. Leaving this setting on auto allows the system to over-allocate memory as the context window grows, leading to an immediate crash. These manual boundaries are the only way to maintain stability during a million-token session. Now we will define the agent's memory parameters. Open the local configuration file where the system's memory bank is managed. Update the max context parameter to 1 million tokens. This split-screen comparison illustrates the change in scale. A standard prompt is limited to a few thousand tokens. This expanded grid holds 1 million, allowing the agent to process massive datasets simultaneously. You can now move your entire software repository, roughly 3,000 pages of code, directly into this memory bank. Check your terminal for the final confirmation. A log entry will confirm that nearly 1 million tokens have been successfully loaded into the active context. This scale allows the agent to analyze the entire codebase as a single unit. It can identify cross-file dependencies that smaller models would miss because they only see the code in fragmented pieces. Before starting the autonomous loop, we must establish least privilege API boundaries. This ensures the agent can only edit the specific files you have authorized. We will also set an automated circuit breaker by limiting the agent to a maximum of 5 file edits per minute. This trigger serves as a safety mechanism. If the agent attempts to exceed this limit or use an unauthorized tool, the system will immediately sever its connection to the repository. A triggered halt will produce a red "execution halted" message in the terminal, indicating that a guardrail has successfully stopped the process. Now that the safeguards are active, initiate the testing pipeline by entering the execute command. These automated constraints are what make an autonomous loop reliable. They turn raw model output into a controlled enterprise-grade development tool. The agent is now working autonomously within the sandbox. It is generating software tests, executing them, and refining the code based on the results it receives. The terminal will display a stream of green test passed notifications as the agent successfully validates each component of the codebase. When the process is complete, the monitor will show a 100% progress bar, confirming that the entire suite has been tested without human intervention. We have successfully deployed a 30 billion parameter model with a 1 million token context window, running a full autonomous workflow on a single GPU. This framework can be adapted for other high-security tasks, such as generating internal documentation or modeling supply chain data, while keeping all data local. Mastering this deployment structure moves the capability of frontier AI from centralized cloud providers directly onto the hardware you own and control.